Today we're in section 10.6, which is equations of circles. And we're going to learn today how to write an equation of a circle in a coordinate plane. We need to know two pieces of information first. We need to know the radius of the circle, and we need to know the center of that circle, that center point, that x and y value that would be that center point of the circle. We're going to be referring to the center as with h and k, talking about h being its x value and k being its y value. Now, I want to first, before we go into the equation, explain to you how they came up with this equation. When we're talking about a circle, we're talking about an infinite number of points that are a certain distance away from that center point. So when we're talking about the distance between that center point and any point that's on the circle, we're of course talking about the radius. And to find that length, to find a radius, we could use that distance formula to say the difference in the x value squared. So I'm going to say I'm calling this x comma y, any point on the circle. So x minus h, quantity squared, plus the difference in the y value squared, y minus k, quantity squared. This is pretty much the formula for area of a circle. The only difference is we don't leave it in terms of just an r is equal to the square root of. We will actually square both sides to leave it in terms of r squared. So that radius squared is equal to our x minus h, quantity squared, plus a y minus k, quantity squared. That right there is the formula for the equation of a circle. The r, of course, being our radius, and our h and k representing the center point. Notice that we still have an x and we still have a y in this equation, because we could then, given any point that's on the circle, given any x value that's on the circle, find the exact coordinate, the exact location of its y coordinate as well, the exact spot where its y would be. So it would help us to find other points that are on the circle as well. The equation of a circle also gives us a pretty clear picture of what the circle will look like. We can see what its center point would be, and we can see what its radius would have been also. So the first question that I have up here is just what would the equation be if the center is the origin? So if the center was at 0, 0, what would the equation of our circle look like? Well, when we're talking about the equation of our circle, we know we're leaving it in terms of r squared. We don't know the radius here. So we're going to say r squared would equal, we could say x minus the x value of your center, so x minus 0, quantity squared, plus the difference in our y value, so we're going to say y minus that 0, quantity squared. Notice it's always minus that quantity. So if this had been a negative number, be careful, because minus and negative, of course, would give us a positive value here too. So just something to be aware of. Now this one I can actually simplify a little bit. R squared is just going to be an r squared. But x minus 0 is just going to be an x squared plus our y squared. Now this would only be the equation of our circle if that center point was the origin. We're going to be taking a look at some examples, and you're going to try them on your own first, of given different center points, fill those in, and then also the same thing, given a radius, make sure we can put that into our equation as well.